Why are there not more people talking about space debris? Imagine looking down at Earth from space. You see the blue planet, the clouds, and the continents. Now imagine this view being slowly cluttered by a growing collection of objects. Some are big, like buses, while others are as small as a flake of paint. This is our space neighborhood, and it's getting crowded with junk. This junk, orbiting our planet at high speeds, is called space debris. Space debris is a collection of human-made objects in orbit around Earth. These objects are no longer functional. They are remnants of our exploration and use of space. This debris field poses a significant risk to active satellites, spacecraft, and even the International Space Station. Space debris includes a variety of objects. Defunct satellites are a major contributor. These are satellites that are no longer working. Spent rocket stages, parts of rockets left behind after launch, also make up a large portion of the debris. Even small fragments pose a risk. Bits of paint chipped off rockets and satellites, bolts, and even frozen coolant can cause significant damage. These tiny particles travel at incredibly high speeds, making them potentially destructive. The problem of space debris is a direct consequence of our activities in space. Every launch, every satellite deployed, adds to this growing cloud of debris. As we continue to explore and utilize space, we must also address the problem of space junk. Space debris comes from various sources. Collisions between satellites are a major contributor. These accidents create thousands of new pieces of debris, each capable of causing further damage. The accidental or intentional destruction of satellites also adds to the problem. Discarded rocket stages are another major source. After delivering payloads into space, these stages are often left in orbit, where they can break down into smaller pieces. Even everyday operations in space contribute to the problem. Routine procedures, such as releasing thermal blankets or separating spacecraft components, can create debris. Every piece of debris, regardless of size, poses a potential threat. The high speeds at which these objects travel turn even small fragments into dangerous projectiles. As the amount of debris increases, so does the risk of collisions, creating a dangerous cycle. Space debris poses a significant threat to our space infrastructure. Satellites, essential for communication, navigation, and Earth observation, are at risk of being struck by debris. A collision can disable a satellite, interrupting vital services on Earth. The International Space Station, home to astronauts conducting research, is also vulnerable. The station has to maneuver regularly to avoid potential collisions with debris. Even small impacts can cause damage, putting the lives of astronauts at risk. As we rely more and more on space-based technologies, the threat from space debris becomes increasingly critical. Protecting these assets is not only about preserving our investment in space, but also about safeguarding our technological future. The most alarming scenario is the Kessler Syndrome. This is a chain reaction where one collision leads to more collisions. Each collision creates more debris, increasing the likelihood of further impacts. This escalating cascade could eventually make certain orbits unusable. Imagine a cloud of debris so dense that it resembles a minefield. Satellites and spacecraft would have to navigate this hazardous environment, facing a constant threat of collisions. The Kessler Syndrome could cripple our spacefaring capabilities, limiting our access to space. While the Kessler Syndrome might seem like science fiction, it is a real concern. We are already seeing an increase in close calls and near misses in space. Addressing the problem of space debris is crucial to prevent this catastrophic scenario. The good news is that there are solutions to the space debris problem. Scientists and engineers are developing innovative technologies to address this challenge. One solution is deorbiting. This involves bringing down defunct satellites or spent rocket stages in a controlled manner. Another approach is active debris removal. This involves capturing large pieces of debris and removing them from orbit. Several technologies are being explored, including nets, harpoons, and even robotic arms. International cooperation is crucial for addressing this global challenge. Sharing information about space objects, coordinating space activities, and developing international regulations are essential steps. By working together, we can create a cleaner and safer space environment for all. The future of space exploration depends on our ability to address the space debris problem. We need to act now to protect our space infrastructure and ensure the sustainability of our activities in orbit. This is not just a technical challenge, but a shared responsibility. We must promote responsible behavior in space, encouraging sustainable practices and international cooperation. By raising awareness, investing in research, and implementing effective solutions, we can pave the way for a future where space is accessible and safe for generations to come. The stars have always beckoned humanity, inspiring us to explore the cosmos. It is our duty to ensure that our journey into space is a responsible one, leaving a legacy of exploration, not destruction. The cosmos is vast, and it holds endless possibilities for discovery and wonder. Let us work together to keep it that way. If you enjoyed this video, please like, comment, and subscribe for more content on space exploration.